January 2011, M1, question 5. Part 1, find out when the velocity is 0, so that's when 0 equals 16t minus 3t squared. So 0 equals t upon 16 minus 3t gives us two solutions, t equals 0 and t equals 16 over 3, 5 1/3 seconds. Part 2, find an expression for the displacement. Displacement is the integral of velocity. If I integrate 16t, I get 8t squared. Minus 3t squared becomes minus t cubed, and I have plus c. If I read the question and get the boundary conditions, I get that when t equals 0, the particle is minus 10 from a fixed origin. So when t equals 0, s equals minus 10, so that tells me that c equals minus 10. Gives me an equation for displacement, 8t squared minus t cubed minus 10. Part 3, distance travelled. So when t equals 0, s equals minus 10. When t equals 1, s equals 8 minus 1 minus 10. So that is minus 3. So if we have a fixed origin, the particle has moved from 10 metres away to 3 metres away, so the particle has moved 7 metres. Part 4, maximum velocity. Maximum velocity occurs when dv dt equals 0. So that's when 16 minus 6t equals 0. 6t equals 16, t equals 8 over 3. Tells me that the maximum velocity is going to be 16 times 8 over 3 minus 3 times 8 over 3 all squared, which equals 64 over 3 metres per second. Because we've been asked for a maximum velocity, we have to prove that is a maximum velocity. So d2v dt squared will be minus 6. That's less than 0, therefore the velocity is a maximum.